All right, so today we're going to be doing 7-7, which is solving logarithmic equations. So for this particular lesson, everything that we've done up to this point is a prerequisite skill to this lesson. So I'm going to be referencing skills you've learned from 7-3 up to 7-6. So the expectation is that you know how to do those things. Now, here's something really cool about this is typically you want to try to isolate x when you solve any equation. Sometimes the x is in the logarithm, so you got to isolate that as well. So your goal is to isolate x as much as you can for the first step. Now, what's cool is if you end up with a 0 inside your log, like just log of 0, or you end up with a negative number inside the log, that automatically tells you at that stage that there is no solution and you do not have to proceed with solving. Now, if you do proceed with solving, your solutions will be extraneous, okay? And then the next rule is to solve logs with the same base on both sides by setting the insides of the log equal to each other, okay? And then checking for extraneous solutions. So we're going to practice all of that together. Okay, so for question number 1, I see that I have a log isolated on one side of the equation is equal to a number. So when that happens, I want you to use the arrow method. And the way to remember this is you always say, I always recycle my logs, because this looks like a recycling symbol, right? So I have 16 to the power of 5 halves is equal to x. So all we now have to do to get x is to do 16 to the power of 5 halves. So if you're still working with using one of these basic calculators, you're going to type in 16, the base. You're going to hit the y to the x button, parenthesis, 5 divided by 2, close the parenthesis, equals, and you should get good, 1024. So when you have a fractional exponent, you can either convert it to a decimal, 2.5, so 16 to the 2.5 power, or do the division in the calculator. All right, next question. Once again, I have log of something equals a number. I'm going to use the arrow method. That's x to the power of 3 halves is equal to 27. Now, our goal is to solve for x, so we need to get rid of what on the x? Good, and how can we get rid of an exponent? By putting it to the reciprocal power, right? So isn't it true that if I put both sides to the power of 2/3, that maintains my equation, balance of my equation? But what is 3 halves times 2/3? 1. Not 0, but 1. So this cancels out and leaves me with just x equals. Now if you do this in the calculator, you're going to end up with 9. Okay. So that's one way to do it. Probably the easiest way to do it. So when you have to get rid of an exponent on a letter, a variable, use reciprocal exponent rule. Okay? So once again, we're going to use our arrows. And you have two options here. You can solve it the calculator way, or you can solve it methodologically. I don't know if that's the word I'm trying to think of. So isn't it true that 64 is the same thing as 2 to the 6th power? So then if I want to bring it up to the numerator, what can I do with that exponent to bring this up to the numerator? Anyone remember?
Multiply with your no, make it negative.
Negative, make it negative, very good. So now my answer is just x equals -6. Now, say you hit a roadblock, you just can't think of what to the 64, I can't think of how to do it. I want to show you how you can do it with the calculator, okay? It's a little more work, but I will show you, so you don't have to copy this down unless you absolutely want to, it's your choice. So the other way you could have went about this is you could add 2 to the x is equal to 1 over 64. And then what you could have done is taken the log of both sides. And you can often use this. This is one of those things, okay? A lot of students get frustrated when they don't get it the first time. There are plenty of times when I'm solving an equation, my first approach isn't necessarily the right one and I have to backtrack. And that's just the reality of doing higher math. sometimes you're going to have to think and try something and it might not work, and then you have to go back and try something else. And that's perfectly fine. And then I'm just going to divide by log of 2. And if you put this in the calculator, you would get -6, okay? So that's the other way you could have went about it as well, if you wanted to. All right, so just a reminder that you can use the calculator. All right, so here, once again, we're going to use our arrows. X to the -3 is equal to 1 over 125. So now that we've been working with these for a while, I want to see what you guys can recognize. Isn't it true that I could rewrite x to the -3rd power as 1 over x to the 3rd?
Yeah, so you can get rid of the negative.
Yes, you can get rid of the negative. Now, if you think about it, we have the 1's on the top is the same. The only thing that's different is the bottom. Is there some number I can put to the 3rd power that would give me 125?
5.
See how you can use a methodological approach? Whatever word I'm trying to say, you get what I'm trying to say, right?
Yeah.
Okay. It's a very hard word, you know, but you get the idea. So you're basically saying what this log says is x to the power of -3rd, or -3, is equal to 1 over 25. So 5 to the power of -3 is equal to 1 over 125. And like I said, you can use the log row on both sides and do it that way too, if you want. All right. Now here, first thing you have to do is make sure that your log is by itself. So what do I need to do with that 1?
You need to move it to the other side.
Good, add it to the other side. That gives me log base 2 of 2x minus 6, is equal to 4. And now, just like before, we use our arrows. 2 to the power of 4 is equal to 2x minus 6. What is 2 to the 4th power? Thank you. And now you just have a pre-algebra problem, right? Add 6 to both sides, you get 22 equals 2x. Divide by 2, you get x equals 11. So my expectation in this class is that you all know how to solve this, so I don't go through it in as detailed steps as we would in like an Algebra 1 class, okay? So any questions about that? All right. What do you think we're going to do here first?
Move the 9.
Good. We're going to use the arrows, right? Recycling. Always recycle your logs. And then what? What would we do from here?
Do that 2 over 3.
Good. 9 to the 3 over 2, which I believe is 27. And then everybody knows how to solve it from here. Just divide by 2, and we get a 13.5 as our answer. All right. So here's kind of this is like totally new stuff compared to what we were doing before. Had a lot of stuff that we've kind of talked about. So first thing you want to do here is you want to check that the base of your logs is the same. What do you think here? Yes or no? Yes. So once you verify that, you can then just set what is inside the logs equal to each other. Like that. Okay? Now, I see that it's a quadratic. And in order to solve quadratics, I'm required to factor, right? So to factor, I'm going to have to get it into standard form. To get it into standard form, I'm going to have to move that negative 6x to the other side, like that. And now this is equal to 0, right? And now, do you remember doing this?
Yeah, it would be -4, -2.
Good, -4, -2. If anybody's lost, we're looking for factors of 8 that add up to -6. That's how you factor a quadratic.
And then you would equal it to 0, so it would be x equals 4 and x equals 2.
Good.
And I would assume you plug it in to see if there's an extraneous solution.
Yes. So here's the thing about the extraneous solutions that's really cool is you don't have to kind of go and write it all out. All you have to really check for is if you get a negative or a 0 inside the log, and if it does, that means it's extraneous. So if I plug in 4 here, is that going to give me a 0 or a negative? 4 squared is 16 plus 8?
24.
Yes. Do you have a question?
No, I was
Oh, okay. And then over here we have 6 times 4, which is 24. This one's good to go. Okay, there's no negatives, no zeros. Now, if I plug in 2, 2 squared is
4,
4 plus 8,
12,
6 times 2.
12.
12.
That's good. So neither one of these are extraneous. These are both valid solutions. It'd be extraneous if it came out to something negative or 0. All right, next one. You ready?
Why did you just multiply 6 times 0? Not for x.
I plugged 2 in for x.
Oh, that makes sense.
All right, so we look. Our base is the same. So what can we do with the insides?
You can just set them equal to each other?
Yes. Then we get the 2x to the other side and rearrange it so that it's in standard form, right? It's a little laggy today. We work with what we got.
-5 and 15.
Good. -5 and +3 multiply to give me -15, but add up to -2. So I set these each equal to 0, and I get these two possible solutions. I don't know if they are true solutions yet, because I have to verify it. Okay, sorry. So now we're going to plug these in. So if I plug in 5, I get 5 squared, which is 25 minus 15.
10.
And then 2 times 5.
10.
This one's good. Now, right off the bat, if I plug in the -3 into this one, what's the problem?
Negative.
So this one is extraneous.
Okay, so assume, like if one of the solutions is negative or 0, it's automatically not a solution, but then if it's not, you have to check them.
You always check it, but the cool thing about this is, yeah, you're saying you want the two sides to be equally to each other. Yes, but the cool thing about extraneous solutions with logs is when they're not, it's always because they're negative or 0.
Oh, okay.
Yeah, so it just saves you the time. So the next one here, same base, so you can set them equal. I have to write so much slower than my natural writing speed on here. So I always feel like I'm going so slow. And then you guys will be like, oh, I'm going fast. And I'm like, oh, really? I'm going fast? It's like having to write. It's like having to write in slow motion. That's how it feels to do. If you guys were ever curious. So it's like this. And then I add the 10 over as well. And then I factor.
-5, -2.
Very nice. You guys are getting better at the factors as time goes on, I see. We got 5 and 2. We got to check them. Right off the bat, I see a problem. 3 times 2 is 6 minus 10.
-4.
Bad. No good. But the 5 is perfectly fine if you check it.
It's fine.
So as time goes on, you'll get faster at checking your work. Anyone have any questions about these?
I was really worried, to be honest, when it was new, but it's like not new, it's just two things mashed together.
That's pretty much how math goes. Like, it's something new, but it really just is like you kind of merging your knowledge into one topic. If you notice, I feel like it's a pretty common theme in this class, so.
That's why I don't like it, because I don't want to go sit through my brain learning about different concepts and stuff.
Well, that's kind of how life works. You usually have to build off of knowledge you already have. We're not going to start you guys learn the ABCs all over again. All right, so the equation y equals y, w, that's definitely a w, equals 93 times log of d plus 65, represents the wind speed w in miles per hour near the center of a tornado based on the distance d the tornado traveled. A tornado with the highest wind speed ever measured of 318 miles per hour devastated Oklahoma City in May of 1999. Based on this wind speed, estimate the distance the tornado traveled. So, if they give you an equation in a word problem, that's like hitting the jackpot in math, okay? You don't have to make your own equation, so very nice. It's barely even a word problem at this point. That means they're going to give you at least one piece of information. Now, this is where they try, this is like the, what's the word? Like the trail that they don't, like the off trail. They're trying to like give you that 1999 to kind of throw you off track. But it's really irrelevant. There's nothing in this equation that indicates time. This is wind speed and this is distance, right? So automatically I see that time is not relevant here. Does everybody see how I was able to determine that? So here, this right here, is this wind speed or is this distance that they're giving me?
Wind speed.
Wind speed. And you can kind of indicate that by the miles per hour, as well as they say highest wind speed right here. Okay? So we're going to plug that in for W. And when I do that, I'm going to write it on the other side. You'll see what I mean. Okay, this is like extra slow motion today. What's going on? So everybody see how I just wrote the W on the other side? I didn't change anything, but you're going to see why. So then my goal is to get D by itself, so I'm going to subtract 65 on both sides. Which is 253. Divide by 93. Now, if you try to do 253 divided by 93 in the calculator, it's a pretty nasty decimal. So for that reason, I don't want you to write a decimal approximation just yet. I want you to leave it as a fraction. Anybody know why I would recommend that over rounding it this early?
Can you simplify it in a fraction?
Unfortunately, I don't think it simplifies. And nor do you want to waste the time on it, because we're going to eventually just do the calculation.
Oh, you're doing log.
So here's the thing. If I try to, that's not the answer yet. So you don't want to start rounding early on in the problem. Why would that be bad? Yeah, it's going to change the final answer. If somebody was calculating something really important, like, I don't know, safety in a car's airbags or something, the pressure that it needs to come out, would it be a good idea? Obviously, we know that any kind of like math will require us to be doing multiple steps throughout, right? They're not going to round that until the very end because they want it to be as accurate as possible. If you start rounding throughout each step of the process, it's like playing the telephone game. Your answer is going to get further and further away from the real answer, okay? So don't round until the end. Why was I able to just put a 10 here as the base?
Because that's the automatic base when there's no base.
Exactly, implied base. So now we can use the arrows, recycle, the recycling symbol. 10 to the power of this.
I like how you just said 10 to the power of this.
Yeah, I don't want to say that again. You know, it is what it is. So D is approximately equal to 525 miles. Why is this not miles per hour?
Because it's distance.
Exactly. Distance is miles. Well, it can be miles. In this case, it is. Could be like kilometers as well. All right. So that's pretty much it for your lesson. I want you to be careful on number 5.